Coming up in this episode, the Wright brothers' cousin Dave, swimsuits for short people, and bungled experiments. All this, plus when bell ringing was a crime on...
Didn't know bell ringing was a crime.
Oh, yes. A lot of strange things have been made illegal over the years. I was once arrested for singing in an elevator.
Wow. I didn't think that was illegal. How did they catch you?
They found my fingerprints on the piano.
Click. Tuesday. I always hated Tuesdays, and I hated them more when things were quiet and there was nothing good on TV. I was carefully inspecting the insides of my eyelids when the phone rang. It was Frank Tank, the director of the City Museum. Seems there'd been a robbery and he wanted me to catch the thief. I'm on the case, I said. I knew I'd be there before he knew it. I also knew that pumpkins are actually fruit, and the fear of frogs is herpetophobia. When I arrived, Tank excitedly explained that the priceless Putuztat diamond had been stolen from its display case. The burglar alarm had gone off, and the police sealed the place before anyone could escape. 3 people were found, so one of them must be the thief. My job was to find out which one. There was Dr. Doris Dortmeyer, international expert on elephant dancing, who'd been studying on the 2nd floor at the time. There was Arthur Scrubb, the cleaner, who'd been polishing the floor. And the last suspect was some dame who claimed she got lost looking for the toilets. A likely story. But who was it? The police had searched the whole building and everyone in it and found no trace of the diamond. There had to be a way of finding out who had broken the display case. Then it hit me. Fingerprints. As every good detective knows, the skin on the ends of fingers forms a pattern of ridges and valleys. This pattern is different for every finger of every person in the world. No 2 people have the same set, not even identical twins. When you touch something smooth, oil and grease from your fingers leave behind a pattern in the shape of the skin. These are fingerprints. If I found fingerprints on the case and matched them with one of the suspects, I'd have my criminal. Normally, fingerprints are very hard to see, but a good detective always finds a way. I needed some special fine powder and a paintbrush, which luckily I had on me. I carefully brushed the powder onto the glass. Because fingerprints are greasy, the fine powder should stick to them and make them clearly visible. Using an ink pad and paper, the police took the fingerprints of the suspects. Because the patterns are so detailed, you have to be careful not to smudge them too much. Using my trusty magnifying glass, I looked for a match. There are 3 different types of pattern that police and detectives look for. Loops, arches, and whorls. These features form unique combinations that can easily be compared with fingerprints of known criminals. Aha! I had a match. The fingerprints on the case belonged to Arthur Scrubb, the cleaner. But wait, all my finely tuned instincts told me Scrubb was not the thief. I smelt a frame job. No, the real crook was Frank Tank, the museum director. He denied it. Asked me for proof. My evidence was the gloves hanging out of his pocket. That's why he'd left no fingerprints. Of course, finding the diamond on him would be the best evidence of all. The whole building had already been searched, so Tank must have it. Strange. Of course. It was the old hide the jewel in the glass of water trick. Tank tried to make some tracks. But with a little help, I soon slowed him down. So another case was closed. All this crime fighting sure made me thirsty, though. Ordinary tap water is a very versatile substance. You can see through it. You can drink it. You can play with it. Keep fish in it. Wash in it. Skate on it. And you can even sleep on it. But not a lot of people know that you can bend it. That's right, you can bend water. Now, this may sound like a strange thing to say. If you can't actually grab hold of some water, you would think it would be hard to bend. But it is possible. When you get right down to it, the smallest bit of water you can have, called a water molecule, is shaped like this. It's made out of 1 atom of oxygen and 2 atoms of hydrogen, and they share electrons, which form a kind of cloud around them. But the sharing is not equal. The oxygen attracts the electrons a bit more than the hydrogen does, so they go more there. Since electrons have a negative charge, the oxygen end of the molecule tends to be negative, while the hydrogen end is left slightly positive. This means the water molecule has positive and negative poles, a bit like a magnet has north and south poles. But these are poles of electric charge, not magnetic poles, so water is not attracted by a magnet. Rub a ballpoint pen on some wool, and the pen becomes negatively charged, like this. It has attracted some electrons from the wool. Now bring the pen near the stream of tap water. The negative charge on the pen will attract the positive charge in the water and bend it like this. And the wonderful thing is that even when it's bent, ordinary tap water is still good to drink. Or play with.
Hello there. In the late 20th century, Dr. Lucky Descartes performs a daring experiment in time and space travel, but is accidentally transported to a parallel universe called Dimension D. Is Lucky doomed to travel forever in Dimension D, a universe where nothing works for you unless you know how? Last time, Lucky had just helped a hairdresser with reflections when Barry, her faithful assistant, tried yet again to bring her home. Once more, she was transported to another time, another place, another crisis in Dimension D.
What the? How did you get in here?
Through a space-time vortex. What's going on here?
I almost pulled off the job of the century. 1,000,000 spaloos from the first bank of dementia.
You almost pulled off the job?
I couldn't go through with it. Oh, stealing is a crime.
Oh, shouldn't we be getting out of here then?
That's what I was trying to do when you came along. There's just one problem. I've forgotten how the engine works.
But the police will be here any minute. Hang on a second. Here, I'll show you. Which bit can't you remember?
I can't remember what happens to the fuel.
Fine. All that happens in the cylinders. Draw me an engine cylinder. Hurry.
Okay. Well, inside the engine is the cylinder. At the top there's a valve. Up here is a spark plug. And down the bottom here is the piston.
Now what happens when the piston moves down?
The piston moves down, this little valve opens, and the fuel comes in. It's like a spray all mixed with air, and it's very explosive.
Go on.
Once the cylinder's full of fuel and air, the valve closes. Then the piston moves back up and compresses the mixture so it's even more explosive. Then
the ignition system connects the battery to the spark plug and makes it fire.
Of course! And when you have a spark in an explosive gas mixture, you get a powerful explosion. The force of the explosion pushes the piston down. That's when the engine gets its power.
Right. After the power stroke, another valve opens. The piston comes up again and pushes the burnt gases out. And then you're all ready to start over again.
All right, just like this engine cylinder model. Come on, baby. Come on. Go. Go. Yahoo! Oh, no. Oh, no.
Now what's the matter?
Some thief has stolen the tires.
Hang on, Dr. Descartes. I'm going to try to bring you back one more time.
What do you know about handcuffs? Oh, no.
Hello there. I'm Thomas Edison. Since the beginning of history, lightning storms have been frightening and mysterious things. Things you should take shelter from. Often, though, taking shelter could be very dangerous. In the city of Paris, people believe that ringing church bells could make lightning storms go away. But this practice resulted in a number of dead Parisian bell ringers. It was bad enough that churches were dangerous places during thunderstorms, but lightning tended to strike anything high up above the ground, and whenever it did so, the results were very serious indeed. People needed help, and eventually it came from a man called Benjamin Franklin. Ben Franklin lived in America and became famous as one of that country's founding fathers. But in his spare time, he was also an inventor and a scientist. One of the many things Ben liked to play with in his spare time was electric charge. You can build up an electric charge on certain objects by rubbing them together. For instance, if you rub a balloon with a piece of wool, the balloon will become covered with electric charge. It was well known that objects with an electric charge on them could get rid of that charge if you brought them close to another object stuck in the ground. It got rid of that charge with a sudden and violent reaction called a spark. As Ben tried various experiments with charged and grounded objects, he noticed one very interesting thing. As he brought a charged object near a grounded object that was blunt or round, once you came really close, say a couple of centimeters away, a spark would jump between them. But if you brought your charged object near a grounded object that was pointy, the charge would disappear once it came within about 15 centimeters or so. And often, you got no spark at all if you brought it closer. He tried it again. But 15 centimeters away from the pointed grounded object, the charge seemed to dribble away with no spark at all. The point seemed to have a special attraction for the charge, and it drew away the electric charge before a spark could jump. Very interesting. Ben figured that the sparks he had been playing with were very similar to lightning. He believed that thunderclouds were full of electric charge, and that lightning was the big spark you saw when the charge jumped to the ground, often through the nearest tall object. It was then that Ben had a terrific idea. If a grounded pointy rod could drain off a charge before a spark leapt, then if he put one high in the air, it might be able to draw the charge out of a thundercloud before lightning struck. He decided to test his idea and attach a pointy metal rod to a church spire. Unfortunately, the local church spire was still being built at the time, so there was only one thing to do. He would go fly a kite. But he wasn't flying the kite for fun. The kite was fitted with Ben's new high-tech pointy bit of iron. If he was right, and the storm clouds were just like charged objects waiting to give off a spark, the iron point would draw some of the charge out of them before the lightning struck. That charge would come down the wet string, and Ben would be able to detect it. He was right. He was also real lucky not to have been hurt, despite being an expert on electricity, and you should never try this experiment. But he was right. The clouds were just big charged objects, and lightning was just a huge spark leaping to the ground. Straight away, Ben wrote to people telling them of his experiment and what it meant. What it meant was that you could protect tall objects from being struck by lightning by attaching a lightning rod, a metal spike connected straight to the ground. The charge could be gently drawn out of the thunderclouds into the earth, And even if a lightning bolt should suddenly strike, the connection to the earth would conduct the charge away without harming the church, or the ship, or the tower. Ben's idea, although a very good one, was rather slow to catch on. That was until one day in Italy when a thunderstorm took place over an armory. An armory was a place where people stored lots of gunpowder. This one contained 79 tons of the stuff. When lightning struck, the results were catastrophic. This incident quickly made lightning rods very fashionable. Gentlemen had them installed on their umbrellas. And ladies even started wearing them on their hats. These were just passing fads. But what was important was that people put lightning rods onto tall buildings, and these are here to stay. So, some of the mystery of lightning had been solved, and tall buildings became much safer places. And, just to make sure no one else was hurt, the city of Paris made it illegal to ring church bells during a thunderstorm.
Inventor of the record player, the ticker tape machine, the loudspeaker, the electric pen, and of course, the light bulb.
What about the electric blues bagpipes?
No, I did not invent the electric blues bagpipes. I don't know who invented that.
People have been trying for a long, long time to fly gracefully like a bird through the air. Despite all of these efforts, they have never been able to. So why is it that birds can fly so well? Birds are built for flying. They have feathers, wings, and very lightweight bodies. All birds have feathers. As well as keeping them warm, feathers make a very lightweight wing used for flight. Bird wings are so successful for flying that aeroplanes use the same basic design. Wings are curved so that air moving over the top of the wing has to travel further and faster than air moving under the bottom. This causes a low pressure area to occur above the wing, which lifts the bird when it flies. However, many birds need to flap their wings in order to stay up in the air. When birds flap their wings, air is pushed down and behind the bird. In this way, a bird lifts itself upwards and forwards at the same time. Even the most sophisticated of human wing designs cannot match the bird wing. As well as having feathers and wings, birds must also have very lightweight bodies in order to fly. They achieve this by having thin, hollow bones and a very light beak instead of teeth. Because people do not have these features, they have had to come up with other ways of peacefully gliding through the air.
Before I invented the light bulb, the best way to see in the dark was to burn something.
Sorry about that. I couldn't see anything over here.
Yes, burning things was mankind's only way of producing light. But plants and animals have been making their own light for millions of years. Can you say bioluminescence?
No.
Go on, it's easy. Bioluminescence is the kind of light produced by fireflies. The light is produced when two chemicals in the creature's body combine to produce energy in the form of light. This reaction is nearly 100% efficient compared to my light bulb, which can only turn about 25% of the energy it uses into light. The rest is wasted as heat.
What about electric blues bagpipe music then?
No, the light bulb doesn't make music.
You should have invented the electric blues bagpipes then. Ooh.
And why do these creatures produce light? Some do it just to see, like this flashlight fish. Others do it to attract a mate, like this firefly. Or some do it to attract prey, like this anglerfish. Even the humble bacteria are capable of bioluminescence, although nobody knows why, and you'd need this many of them just to make the same light as my 60-watt light bulb. I don't know what that number is called, but I do know it's very large. My favorite bioluminescent animal is a kind of beetle found in the jungles of Asia.
There, the jungle is too thick for a female to see the light of a single male, so hundreds of males climb into the same tree and flash their lights on and off at the very same time, making the jungle look like it's full of Christmas trees. Ah, that's better than setting fire to things, isn't it?
As anyone who can see will tell you, people come in different shapes, different sizes, and different colors. Not so light, light, and dark. While the difference between people's color may seem very large, it really isn't. Skin is made up of a number of very thin layers. One of these layers has special cells which produce a type of coloring called melanin and pass it onto the rest of the skin. People have about the same number of these cells in their skin no matter what color they are. That is 9,300 per square centimetre. It's just that some people's cells produce less melanin than others, making them paler. And some people's melanin tends to turn up in patches called freckles. When the sun shines on you, the ultraviolet light can give you a sunburn. This is when some skin cells are damaged or even killed by the strength of the light. When this happens, blood rushes to your skin to repair the damage. That makes you go pink for a while and it hurts a bit, but it doesn't make you go brown. You go brown when sunlight makes your melanin-producing cells pump out more melanin. The melanin protects the skin from sunburn because the ultraviolet light can't pass through it so easily. So that's what happens when you tan. A long, long time ago, we all lived in sunny Africa, where we needed lots of melanin to protect our skin. But sunburn isn't the only thing dark skin protects you from. It protects you from vitamin D poisoning. When the sun hits your skin, the skin makes vitamin D. Everybody needs just the right amount of vitamin D, but too much can be bad for you. So when there's a lot of sun, a dark skin is useful because it protects you from vitamin D poisoning. However, if it's less sunny, your skin will make less vitamin D. If you don't get enough vitamin D, you get a disease called rickets. That is when your bones are soft and don't grow straight. Pale skin can make 8 times the amount of vitamin D that dark skin can. So when there's less sun, pale skin is a good thing. That's why less sunny places tend to produce people with paler skin. Nowadays, people tend to wear a lot of clothes and move around quite a bit, so you can see people with all sorts of colours everywhere. Of course, too much sun can still damage anyone's skin, no matter what colour it is. So it's wise to cover up, wear a hat, and use some sunscreen whenever the sun is at its brightest. And you can get plenty of vitamin D by eating sandwiches made from the liver of the walrus. That's how Eskimos get theirs.
Hey, brothers and sisters, I'm gonna talk about the big S now. So I want you to give me some skin. It may be brown, it may be white. It wraps around you nice and tight. Skin. It covers you. Skin. It covers me. Skin. Make no mistake, it's good for everybody. Now you know it's the biggest organ in the human body, baby. And you know they don't call it the big S for nothing, brothers. Go! Now skin can burn, and you should know that ultraviolet ain't no go. Skin! It covers you. Skin! It covers me. Skin! Make no mistake, it's good for everybody. Now brothers, you tell me what comes in many colors. Skin! And sisters, what is it that makes the undeniably essential fat-soluble vitamin D? And if I was to mention the big S, to what would I be referring? Skin!
fascinating. Their skin protects them from too much vitamin D, and it protects them from the sun. Ah, don't you just love humans?
I don't know. What do they taste like?
Oh, Pavinia, how could you eat such an amazing creature?
Oh, probably baked in applesauce. Of course, you'd have to take them out of their clothes first. The buttons and zippers would catch in your teeth.
I'd like your help with an experiment. Watch this.
Whoa, wait a minute. It's not hooked up to a kite, is it?
No.
Oh!
Ah, it's tied to your tail.